Today we're going to look at linear programming problems and how you can analyze a linear programming model and solve real-world problems. The key steps that we're going to be doing when we do these, one, we want to read through the problem and define the variables. Then we want to write a system of inequalities. Remember, inequalities means like less than, greater than signs. We're going to graph them. We're going to find the coordinates of the vertices for the feasible region. Write a linear function to be maximized or minimized. Substitute in those vertices and then find the result. All right, so we're going to look at two examples here. The first one says, as a receptionist for a veterinarian, one of Dolores Alvarez's tasks is to schedule an appointment. She allots 20 minutes for a routine office visit and 40 minutes for a surgery. The vet cannot do more than 6 surgeries a day. The office has 7 hours available for appointments. If the office visit costs $55 and most surgeries are $125, how can she maximize the income for the day? All right, so we want to figure out what are the two things that we don't know. Well, from that last sentence, we don't know how many office visits and surgeries she should do. So we want to create two variables. Let's use X and Y, one for office visits and let's use Y for surgeries. Okay, so that's step one. Step two, now we want to write a system of inequalities. So what do we know about these office visits and surgeries? Well, one thing it starts off right away talking about is time. She has 20 minutes for office visits, 40 minutes for surgery. Now, if we're going to be able to write an inequality for that, we need a total. And they do give us a total here in time of 7 hours. Now, the problem is the first two are minutes, the last one is an hour. So one thing we got to do here is a little converting. Let's turn hours into minutes. So if we got 7 hours, we know there's in 1 hour, there's 60 minutes. So multiplying here, that's going to be the same as 420 minutes. Okay, so one inequality here that we're going to write down is she has 20 minutes. 20 minutes for each office visit X plus we have Smartboard's being a little funny here. All right, plus 40 minutes Y for, and that should be less than or equal to the time she has in the day. So less than or equal to the 420. Okay, reading on, now we got, the next thing says the vet cannot do more than 6 surgeries in a day. So surgeries, that's talking about our Y variable. We don't need to include anything with X because this is only talking about surgeries. So if she can do no more than 6, that means the surgeries need to be less than or equal to 6. We don't really have any other inequalities here because the last thing they talk about money, $55, $125, there's no total for that. So that must mean we're going to use that information later once we have our graph. So now the next step is to graph that out. We have our y-axis, we have our x-axis. Okay, let's put the two inequalities. Let's start with this bottom one. That one, y less than 6, so on the y-axis find 6. 2, 3, 4, 5, 6, put a dot there. That one, since we only have y, is going to be straight across here. Okay. And since it's less than, we want to shade everything underneath this. So all this stuff should get shaded in. All right, our next one, the one on top here. This one's a little bit harder to graph. Two things we can do. One, get it in slope-intercept form to graph it, or we can use that cover-up method. This one might be a little bit easier to do that cover-up method. So if we were to cover up the y part of that, we would get the inequality here, 20x is less than 420. Dividing both sides by 20, that would give us 21. So if we find where 21 is down here on the x-axis and put a dot, that's where it should cross through. That's the x-intercept. Let's do the same thing now for y. Let's cover up the x and solve for the y. So if we do that, we got 420 If we take 420 and divide by 40, we are going to get calculator's not being responsive here. So it looks like we get 10 and a half when we divide that out. So now we know the y-intercept is going to be at 10 and a half. So we want to put a dot right there, right at 10 and a half here. Okay, so now our job is to connect those. Now we want to make sure we kind of know what that slope is going to be, so we got an accurate picture. One thing we can do, if we know we got to go down 10 and a half and then over 21, that's kind of like a slope, 10 and a half over 21. Let's see on our calculator what that slope comes out to be, so we can be a little bit more accurate in figuring out what that is. So if we do 10 and a half divided by 21, we get half, or 1/2. So our slope here should be, and it's going down, so it'd be negative 1/2. So we want to be going down 1 over 2 from this. So if we go down 1 over 2, down 1 over 2, down 1 over 2, we should intersect that other point. And it looks like we do. So that's this other line here. All right, and this one is also less than if you plug in 0, 0, which is that corner point there. 0 is less than 420, so we want to be shading on this inside here. So it'll be everything here. So our feasible region, the part that got shaded by everything, is right in here. All our answers are going to come from the corners of this feasible region. So our corner points, or our vertices, are going to be, there's 4 of them here. One is 0, 0. One here is at 0, 6. There's one way over here at 21, 0. And then there's this corner point right here that we also want to label. That one is definitely up 6, because this green line goes across at 6. Over, if we count 1, 2, 3, 4, 5, 6, 7, 9, 10, 9, it looks like is where it's at, 9, 6. So those are the points now that we want to check with our money equation, or our equation that's going to be looking at what needs to be maximized or minimized. So for step 5, our function that's going to be maximized or minimized, then it said that it's $55, okay, for surgeries, or sorry, for appointments, $125 for surgeries. So our X is going with office visits, so that's 55. Our Y, that's 125, that's the surgeries, that's how much surgeries cost. So now we want to check those points that we had just come up with, 0, 0, 0, 6, 9, 6, and 21, 0 in with that equation. So now if we put them all in and see what we get, the one that's the most should maximize this. If we put both 0 and 0 in there, we're going to get 55 times 0 plus 125 times 0. That's not going to result in any money. She doesn't do anything, she's not going to make any money. If we put 0, 6, we're going to have 55 times 0 plus 125 times 6. This one will give us some money. If we multiply that out, she's going to make $750. Let's keep going here. If she does only office visits, 21 of them, it'd be $55 times 21 office visits. No surgeries though, so she's not getting any money from there. This is going to be a little bit more here. She would make $1,155. Last, let's check that combination of 9 office visits, 6 surgeries, so we'd want to take 55 times 9 and 125 times 6. Add those two numbers together, and this one actually ends up being our greatest value. She can make $1,245. So since that's the max, that would be our answer for the problem. And she can do that by doing 9 office visits and 6 surgeries. So that would be our answer for step 7. So that's kind of the process of going through on one of these. All right, let's try one more. So this next one says, you need to buy some filing cabinets. You know that cabinet X costs $10 per unit, requires 6 square feet of floor space, and holds 8 cubic feet of files. Cabinet Y costs $20 per unit, requires 8 square feet of floor space, and holds 12 cubic feet of files. You have been given $140 for this purchase, though you don't have to spend that much. The office room has no more than 72 square feet of cabinets. How many of which model should you buy to maximize storage volume? All right, I want you to pause the video, see if you can, one, come up with the variables. All right, let's see what she did. For this one, the two things we don't know are how many of each type of cabinet, and they kind of made it easy on us, so let's just go X for cabinet X. And let's go Y for the Y cabinet, number of Y cabinets. Okay, next, again, pause the video, see if you can come up with the inequalities for this one. All right, let's check what you got. One thing they talk about here is money. So I see you got money here, here, and they do have a total. So if we get a total, that means we can write an inequality. So let's write an inequality out for that. You got $10 for X. It costs 20 for Y. We have 140 to spend total, so it has to be less than that 140 total. All right, what else do we have a total for? Well, it says we have no more than 72 square feet of cabinet space. So the other thing that we want to write inequality for is the floor space in square feet. So X says it needs 6 square feet, so 6X. The Y cabinet says 8 square feet, so 8Y needs to be less than that. The thing we don't know is the volume. So later on, we're going to deal with those volume numbers when we get to that. All right, next we want to graph this out. So see if you can graph both of these two on your graph now. Pause the video again and try it out. All right, let's see. If you did like the cover up method again, looking at this top one, if you cover up the Y and divide by 10, you're going to get 14 on the x-axis. So that would be right there. And if you cover up the Y and do the same thing, you're going to get 7. That's right there. So if we got to go down 7, that would be like a -7, and over 14, that's a slope of -1/2. So if we go down 1 over 2, that's our slope here. And we should be able to connect these two. Yep. So that's the line for that. And that one, since it's less than, should get shaded in this region. All right, let's do the other one now. On this one, if you do cover up method, if you do cover up the Y, 72 divided by 6 is going to be, let's see, that's 12, or sorry, yeah, 12. So 12 is right here. And then if you take 72 divided by 8, that's going to be 9. 9 is right here. So here on this one, we're going down 9 over 12. 9 over 12. If you simplify that, it's the same as -3/4. So our slope is down 3 over 4. So point there, go down 3 over 4, down 3 over 4, and we connect those. Okay, and this one again is less than, so that's shaded underneath as well. So everything in here. So the feasible region is right in here. So we want to check all those corners again. There's again a corner at 0, 0. There's one at 0.07. There's one out here at 12.0. And then there's this point right here, which is at, if we count over, that is at, looks like 8 over, and it's up 3, so 8.3. All right, so now we got our the points there. Again, why don't you pause the video and see if you can come up with this maximize function for the volume of these. All right, let's see what you got. The volume for x says that it holds 8 cubic feet, so 8x. The y one holds 12 cubic feet, so plus 12y. So now you want to plug in all those points that we came up with and see which one is going to give you the most. If you do 0, 0, you're not going to get any space because 8 times 0, 0, 12 times 0, 0, so that won't get any. Another point that we need to check is 0, sorry, 0, 7. If we check that one, 12 times 7 is going to give us 84, so we could get 84 cubic feet on that one. Another point we said we need to check is 12.0. That one's going to give us 96. And then the last one, we had 8 and 3. So if we multiply both of those and add them up, this one gives us 100. So the most storage looks like we can get is 100 cubic feet of storage. And we get that by buying 8 of the cabinet X's and 3 of the cabinet Y's. So that would be the best one to buy if we want the most storage. All right, you're going to try some of these out now on the practice.